Welcome to session 6 of Unit 3, and in this session we'll be looking at catalysis. By the end of the session, you should be able to define what a catalyst is, state the criteria by which a substance is classified as a catalyst, and then explain with illustration the effect of catalyst on the reaction rate. So, when we say a catalyst, it is a substance that speeds up a reaction without being consumed itself. What does it do? It basically provides a new or an alternative pathway for the reaction with a lower activation energy to occur. So a catalyst is used to lower the activation energy, and when the activation energy is lowered, then it provides an alternative pathway for the reaction to get to completion. So this energy plot for a catalyzed and an uncatalyzed pathway for a given reaction. So like we said, this is a catalyzed pathway and this uncatalyzed pathway. I hope this is self-explanatory. So effective collisions on catalyzed, then we have effective collision on catalyzed. Realize that the product increases here as compared to this one. So this is for uncatalyzed and this is for catalyzed reaction. So there are 4 criteria that must be satisfied in order for something to be classified as a catalyst. What are those? 1. The catalyst must increase the rate of a reaction. 2. The catalysts are not consumed by the reaction. 3. A small quantity of catalyst should be able to affect the rate of reaction for a large amount of reactant. And 4, which is the final point, catalysts do not change the equilibrium constant of or for the reaction. Now, we have 2 types of catalysts. We have the homogeneous catalyst and then the heterogeneous catalyst. Homogeneous catalyst, it is one that exists in the same phase as the reactant. The key word here is the same phase. So, example, iodine ions in the decomposition of peroxide are present in the same aqueous solution phase. When we talk about heterogeneous catalyst, it is the one that exists in a different phase from that of the reactant. Example, the catalyst is solid and the reactants are either liquids or gases. So when we talk of heterogeneous catalyst, the mechanism of heterogeneous catalyst is often complex and not well understood. However, the important steps that are involved are the absorption of reactants onto the surface of the catalyst. Then we can look at the conversion of the reactants to products on the surface of the catalyst. Then desorption of the products from the surface of the catalyst. The absorption step is true to involve chemical bonding of the reactant to highly reactive metal atoms of the catalyst on the surface with the accompanying breaking or at least weakening of bonds in the reactant. So basically, this is all about catalysis. You need to know that a catalyst is a substance that takes part in a chemical reaction, however do not get consumed. They provide an alternative pathway for the reaction to get to completion and thereby lowering the activation energy. So as a session review, try as much as possible to define the word catalyst, explain with diagram the effect of a catalyst on the reaction rate. So we look at the uncatalyzed and then catalyzed. Then we look at effective collisions with uncatalyzed, effective collisions with catalyzed. Then you should be able to state and define 2 types of catalysis, which are homogeneous and then heterogeneous catalysis.